This is volumes of prisms. When you're finding the volume of a three-dimensional object, you're finding a measure of the amount of space that that three-dimensional object occupies. Volume is measured in cubic units, such as meters cubed, inches cubed, centimeters cubed, feet cubed, just to give you a few examples. The volume of a prism is the product of the area of the base and the height of the prism. When we're trying to find the volume, we're trying to find out how many cubic units it would take to construct this three-dimensional object. If I can figure out how many cubic units it takes just to make the base, and then I multiply that by the height, that's basically telling me how many layers of cubic units I'm going to need, and it will give me my volume. For example, if it takes 30 blocks to create this base here, and I know I have to go 3 levels high, I would do 30 times 3, and it would be 90 cubic units to create that shape. Now, the tricky part of prisms is you have to remember that you need to first figure out how many cubic units it would take to fill the base. And the base of a prism can be any shape, but the lateral faces, the middle faces, must be rectangles. So in this case, when I see triangles, I know those must be my bases because the middle pieces of any prism are rectangular. So I would find how many cubic units it takes to fill this triangle, this base, and multiply it by how many layers high I'm going to have to make to create that three-dimensional shape. So the volume of a prism can be simplified to finding the area of the base and multiplying by the height of that object. So let's take a look at a couple of examples. So the first thing I want to do is identify and find the area of the base. When it's a rectangular prism, it really doesn't matter because you're going to have a rectangular middle piece. So I'm just going to use the bottom and the top here as my bases. So to find the area of this base, I would do length times width, or in this case, 6 times 8. Which is going to give me 48. And that is going to be multiplied by my height. I'm going to go 15 layers high. So times 15. And 48 times 15 is going to give me 720 cubic yards. It would take 720 blocks, a yard long on each side, to create this three-dimensional object. Let's take a look at another example here. This time, even though it looks like this rectangle is the bottom piece of this prism, it's not my base. Remember, bases can be any shape, but the middle pieces of prisms are rectangles. So in this case, when I see triangles, I think those must be my bases. So when I'm finding the area of my triangle, I have to make sure I'm finding the two sides that form the right angle. So this will be my base, 5.5 inches, and my height for the triangle is 2 inches. So I'm going to do base times height divided by 2, which gives me a total of 5.5. So 5.5 cubic inches will cover this triangular piece. Now I'm going to build it 4 layers high. If this shape was actually sitting on this triangle, if the triangle was the bottom piece, it'd be 4 inches or 4 layers high. So I'm going to do 5.5 times 4 for a total of 22 cubic inches. Let's take a look at this real life example here. So a movie theater is redesigning their popcorn bags. They have 2 bags, both of which will hold 96 cubic inches of popcorn. They want us to find the height of each bag here. So let's first look at bag A. So bag A has a base with dimensions of 3 by 4. It's going to be a rectangular bottom on these popcorn bags. So I'm going to do 3 times 4 to find the area of the base. And I want to figure out how high it's going to go, how many layers high. But I know it's going to hold 96 cubic inches. So 3 times 4 gives me 12, so I have 12 times h equals 96. I can divide each side here by 12 to find that this bag is going to have a height of 8 inches. Let's take a look at bag B. So bag B's base is 4 by 4. It's a square bottom. So 4 by 4 times however high it's going to be is going to give us 96. So I'm going to get 16 times h equals 96. I can divide each side by 16, which gives me for my height a total of 6 inches for bag B. Now, if they're trying to figure out how much paper it's going to take to create these bags, we can also figure that out, because that might be incorporated into which bag they want to use. They want one that's cheaper to make. Less paper means it's going to be cheaper. So if we want to investigate how much paper is needed to make the bag, we're going to be looking for the bag's surface area. The only thing that we have to take into account is the bags aren't going to have a top. It's going to be open so they can put the popcorn in the bag. So we only want one base piece figured in. So for bag A, the base is a 3 by 4 rectangle, which is going to have an area of 12. The front part of the bag is going to be a 4 by 8 rectangle. And since the front of the bag is going to match the back, I'm going to double that. So I get a total there of 64 for the front and back pieces. Now the side pieces are going to be 3 by 8 rectangles. So 3 times 8, there's going to be 2 side panels. So I get a total there of 48. So I want to add up these 5 sides, and for bag A, I get a total of 124 inches squared. So 124 square inches of paper are needed to create this bag. Let's also look at bag B. Now bag B has a base of 4 by 4. Remember, we're only counting one base because the top is going to be open. It's got a front piece of 4 by 6 and side pieces of 4 by 6. They're all identical. So 4 by 6, and there's going to be 4 of them, which gives us a grand total of 96. So if I add up that 96 and 16, I get a total of 112 cubic inches. So while both bags of popcorn hold the same amount, bag B requires less paper to construct the bag.